Welcome everyone. Today's topic of discussion is massless Dirac fermions. So here we are speaking about fermions. So what are fermions actually? Electrons, protons, neutrons, all these are known as fermions because they follow Pauli exclusion principle. Means they obey Pauli exclusion principle, and according to that principle, no two identical fermions can occupy the same quantum state. That is the Pauli exclusion principle. And all these particles like electrons, protons, neutrons, all these particles are known as fermions because they obey the Pauli exclusion principle. So here we are talking about fermions, but we are talking about actually more specifically massless Dirac fermions. So not all fermions are the same. In graphene, electrons are there, and I have already mentioned that electrons are fermions. So in graphene, there is a movement, there is a motion of electrons when electric field is applied. Okay, so here electrons are fermions, and these electrons are known as massless Dirac fermions. Why massless? You know, electrons are having mass. They are not actually massless. In case of traditional materials, means in conventional materials, electrons move, or movement of electrons become possible when electric field is applied. That means some driving force is there, and depending on the magnitude of the driving force or depending on the magnitude of the electric field, they accelerate, means electrons accelerate. Okay, but here in this special case, electrons become independent of the electric field being applied. Means their velocity, electrons velocity does not depend on the electric field being applied. So their effective mass becomes zero. That's why those electrons in this special case of graphene, we are talking about graphene here right now. So electrons behave as massless particles in graphene, not in all the materials. In graphene, again other materials are also there, like some insulators are there, topological insulators. There also electrons behave like that. So here in this special case, so what happens actually in this case? We are talking about graphene, that means it has a special structure. This is made of single carbon atoms, single layer of carbon atoms, not single carbon atom. It is made of graphene. This is made of single layer of carbon atoms, and they make a structure like honeycomb lattice structure they form. And due to this structure, special energy bands are created known as Dirac cones, and due to this Dirac cones, electrons behave specially. Means we can see special behavior of electrons. What is the special behavior? They act like massless particles. Actually, what happens here in this case, their energy momentum relationship becomes linear. They no doubt follow Dirac equation. Dirac equation is known as a quantum equation. This is an equation in quantum mechanics. You know, Schrödinger equation is there. Schrödinger equation is used for normal cases, means when relativistic effects are not there. And when relativistic effects, means just by combining special theory of relativity and quantum mechanics, the equation was derived by Paul Dirac in 1928, known as Dirac equation. So this is applicable, this Dirac equation is applicable for no doubt quantum mechanics, but relativistic effects are there. This equation takes into account the relativistic effects. What is the relativistic effect? Relativistic effects means when the motion of the particles approaches the speed of light. Okay, means if the speeds are comparable to the speed of light, in that case a relativistic wave equation is used. That means Dirac equation is used. And here, so I was talking about what? I was talking about constant velocity of electrons, which does not depend upon the electric field being applied. What is that constant velocity? The special name is given to that constant velocity known as the Fermi velocity, and that velocity is equal to 1 by 300th velocity of light. You know, velocity of light is equal to 3 into 10 to the power 8. So if you divide the speed of light in vacuum, if you divide speed of light in vacuum by 300, you will get the Fermi velocity, means velocity of electrons in graphene, which is independent or irrespective of the electric field being applied. So that is the advantage. So you can see that here electron mobility is too high. So electron mobility is too high, that means conductivity also becomes too high. So that means this special nature of graphene, due to this special nature of graphene where electron mobility is so high, extremely high actually. Velocity is how much? It is 10 to the power 6 meter per second. And if you talk about electron mobility, it is of the order of 200,000 square centimeter per volt second, that is 2 lakh square centimeter per volt second. So too high is the electron velocity, electron mobility. And if you compare this with silicon, in most of the electronic devices, silicons are used, you know this thing. And there, in case of silicon, this value is approximately 1400 square centimeter per volt second. So if you look at only the numericals, then that was a 200,000 and it is 1400 only. So there is a vast difference. That means by using graphene in electronic devices, we will be able to achieve a much higher speed, actually ultra fast speed. That's why companies and research labs are exploring new ways to integrate this new thing, new science or new technology into existing technologies to make everything ultra fast, means electronic devices. I am talking about electronic devices. They would become ultra fast and power consumption can be lowered down. There will be a drastic reduction in the power consumption by the electronic devices due to extremely high conductivity. Okay, means electrons move through graphene without scattering. So heat dissipation to the surrounding is very less in that case. That means energy waste is very less, and that's why these devices become highly energy efficient. So many advantages are there if you can use graphene in electronic devices. Okay, that means very soon we are going to be, since scientists are working tirelessly on this new technology, so that means we are going to see very soon this new technology, means everything would become ultra fast. We can expect that thing. Anyway, so this was all about today's topic. So what was the main thing? Massless Dirac Fermions. Okay, that was the topic of discussion actually here. And okay, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.